All right, folks, so we're back to some regular Java stuff today. I have a few things that I want to do. I don't have a lot of slides for this particular sort of intro to interfaces. So after we're done with the slides, I'm going to go in and take a look at PA3, specifically the starter code. So to start with today, I want to do a little bit of sort of backtracking stuff, or at least sort of talk about the sort of pet and dog and cat stuff that we were working on before, just to give a little reminder, because it's been a couple weeks. We had some JavaFX stuff sort of mixed in there. So I want to give just a little reminder and talk a little bit about that sort of abstract class thing again. And then we'll talk about interfaces and how they are sort of similar to an abstract class, but definitely different. And ultimately, in the second lecture for this week, you'll see another thing that they get us, another sort of useful tool that they sort of add to the sort of programming stuff that we do. So let's go back and think about the sort of the pet class. Now, we had this issue initially where pet was just a concrete class, and a few things didn't make sense. Stuff like creating a new pet object. That's not really something that we ever wanted to do. Pet was just a bunch of code that was very generic for any sort of pet that we wanted to create, like a dog or a cat or a parrot or any sort of pet that you can imagine. So creating a specific object of this type didn't really make sense. What type of pet is it? What does it say? If you sort of dog says woof, what does a generic pet say? So instead of leaving it like this, where we could create a new pet, we made it abstract. And there's a couple of ways that abstract is used. Of course, you can make a class abstract, which is what we did with pet, and you can also make methods abstract as well. Something where you're just saying this method exists, but I'm going to leave it up to the child class, up to the sort of child class that we create to deal with what that method actually does. And so we did that for says. We made pet abstract as well, so we can't create an object of the pet class, but we can subclass it. So we can create our concrete classes, cat and dog. And of course, that was quite easy to do. We just threw in the abstract keyword in a couple of places and made sure that says didn't have an implementation. It only has the signature and then a semicolon. So we can't make pet objects, and any concrete subclass like dog or cat must implement says. That's what we've sort of made a requirement for any subclass of pet. So this is definitely useful for us. If we draw out the UML diagram of this, we get our nice sort of inheritance arrows here. We have some italicized stuff representing that we've got sort of abstract methods or abstract classes. And then we see that both dog and cat implements says. So if we want to make, say, another pet, like a fish, then really the only thing that we need to do is something like this. We create a fish that extends pet. It has its constructor, of course, and we have to call super. The pet super takes in a string and an ID. So in some way, we have to get those values into super. But in this case, I sort of just hard code fish, but the ID comes in. So you can imagine sort of messing around with something like this and making it so we can create a fish. And then we have to override says. So we don't need abstract methods to make the class abstract either. We could make fish abstract as well. Let's say this is just a generic fish. Well, the generic fish can also be a generic pet. So we could make this fish class abstract as well. So we could sort of have this line of sort of multiple abstract classes. Anything that comes off of fish, so maybe you think of a fish, maybe a goldfish or something. You could have a subclass of fish that is a goldfish. In which case, it is a fish and it's a pet. So you can sort of string these things together, make them abstract if you want to. You certainly don't have to, but you can make multiple sort of abstract classes in a line. And if you take a look at the Blackjack PDF, you see that there is actually two abstract classes in that program. The first one is card collection. The next one is generic player. And it's further down the inheritance chain. So you can make any classes you want abstract. Just remember, typically they are sort of the generic classes for some object. So a pet could be generic for any pet. A generic fish class could be generic for any type of fish. So that's sort of the idea here. You can make more of these sort of abstract classes if you want to. As part of that, you can add their additional functionality. So we have the constructor, we have the says that we need for pet, and maybe the generic fish class has some other abstract method called ideal salinity, where maybe it's just returned, or maybe you compute it or something. So a subclass of a concrete class can be abstract, and that's what you see in the Blackjack game. We've got card collection, then we have hand, and then below hand is another abstract class, generic player. So you can mix and match these in any way that you want to, as long as it sort of makes sense to do so. Again, a fish could just be a generic fish, and then we could have subclasses off of fish as well. So making stuff abstract is a very useful tool for us. It means that the instantiated class that you create, so like dog or cat in this example, will have certain functionality. Pet has that functionality, get name, get ID, and we must implement says, because says is abstract in pet. So dog and cat, we know have those capabilities. We can get the dog's name, we can get the dog's ID, we can use says for the dog. We're guaranteed to have that information available to us, those methods available to us. The abstract methods, and ultimately the inherited methods from an abstract class and inherited data, they define a contract. So I want to point out a couple things in this little code snippet here. So notice that the argument here, or the parameter for make a sound, is a pet. Pet's abstract, so we can never make a new pet. We can never have this sort of new pet thing here. But because of polymorphism, we could send a dog into this. We could send a dog object, or we could send a cat object into this. Or if we sort of think about the fish that we just created, we could send a fish object into this. Or if we had some concrete class after fish or below fish, we could send a goldfish into this. Anything that is a pet, so anything that's below pet in an inheritance chain, we could send into here, and this will work because every single pet has a says. It's guaranteed to have a says because says is part of pet. Yeah, it's abstract, and the concrete classes have to implement it, but we know that if a concrete class, a concrete object is a pet, then it must have says. That's what I mean by defining a contract. Every pet must have a says, so I don't have to do anything special. I can just take the pet object, the dog or the cat or the fish or the goldfish or parrot or whatever pets I have, and I will always be able to call this method on whatever pet that is because it must exist. And that's the same idea for this second one. The second one as well sort of calls make a sound, but notice it's an array of pets, and we did the array of pet stuff previously. We could put dogs and cats in an array of pets. Again, we couldn't say new pet. We can't put any actual concrete pet objects because we can't create it. It's abstract. But we can put dogs and cats in the array. And so that means that dogs and cats are guaranteed to go into here, which means we get dogs and cats up here, and they all have says. They're guaranteed to have says. So that's something that abstract classes bias. They bias this contract. Now, one of the things I wouldn't be able to do, so in this make a sound, I would not be able to do so for cat has hairballs. Cat has this method, but only cat. So I would not be able to do this with a pet like this. We have to check, and this is where you use instance of. We would have to check, is this pet a cat? If it is a cat, we change it to a cat, and then we call has hairballs. But the generic pet object does not have has hairballs, so we could not use that here with a generic pet object. So any of those sort of contracts that we have, we can use. But if something is specific, like has hairballs, we would not be able to use it with the more general object, so the more general pet here. All right, so concrete methods, of course, the things like get name, get ID, you can think of those as sort of the default behavior in something like pet. So that in subclasses, we can avoid sort of having those. If we need to change it, if we need to change what get name or get ID does, then we can do an override, and that's perfectly fine. But that sort of default, sort of general behavior, that should go in your abstract class so you don't have to copy and paste your code. Now, there are some limitations to this. You might sort of think about this or sort of ask this question: how many parent classes can a class have? Obviously, in the sort of world that we live in, we have two parents. So how many parent classes can a child have? If we could have more than one, and some languages allow more than one parent class, that's what's called multiple inheritance, and it sort of causes its own sort of issues and things you have to think about. Java does not allow multiple inheritance, so at most you can only extend one other class. That's it. Now that doesn't mean that we can only have sort of one level of inheritance. It doesn't mean, we'll go back to our UML diagram, that doesn't mean this is all we can do. We could have a child class off of dog if we want to as well. And that child class would sort of be its parent would be dog. It just means that we can only extend one other thing. We cannot have extends and then multiple classes after that. So sort of a direct connection via these arrows can only go to one other class. A language like C++ does allow for multiple inheritance. That can potentially cause some issues, because then you sort of, what if your parents both have the same method but they do different things? Which version of that method do you use? So those are sort of questions that that you sort of have to deal with if you have multiple inheritance. So for us at the moment, we don't have to worry about that, which is actually quite nice. So this is where the interface comes in. The interface is like an abstract class. It creates a contract. It says these methods must exist. That's exactly what pet did. Pet said says must exist in all of my child classes. So an interface does the same thing. An interface says, here's some methods. They must exist. And like an abstract class, it cannot be instantiated. So you can't create an object from an interface. But Java limits you to single inheritance. You can only extend one class, but you can implement as many interfaces as you want. That's the key difference. That's where this flexibility comes from in interfaces. And this is used extensively in object-oriented programming. In fact, interfaces are how we are going to respond to events in our Java FX GUI. So we will be using interfaces. We won't necessarily be creating all of our own interfaces for interactions, but we will be using interfaces that Java FX gives us. There is another keyword here that's very important. It's implement. So the keyword that you use when you deal with interfaces is implements. So a class implements an interface, whereas a class extends a parent class. So that's the difference. If you see implements versus extends, implements means interface, extends means a parent class. Okay, so let's talk about what these interfaces sort of contain, and then we'll do some examples. They can only contain constants. They can actually have other interfaces or classes within them. That's not something that we're going to mess with. So think of it as only constants. They contain method signatures. So they only contain abstract methods. As of Java 8, and this is one reason why you have to have at least Java 8 for this class, you can actually have static methods and default methods as well. We're not going to use them in this class, but you can have them. All the variables that you create, if you create any, are public static final. Most of the time in this class, we won't be creating variables as part of our interfaces, but you can do that. Public static final is going to be a constant. So that's what I mean by they can only contain constants. You actually omit those labels. You don't even put them in. If you make a variable, it is automatically public static final. And all methods are automatically public. So you can't put a protected method or a private method into an interface. And you actually omit the public as well. So interfaces, they make it a little bit easier to mess with because you can omit all of this stuff and just put the signature the way that you want it. So let's do a quick example, and then I'll show you some UML stuff, and then we'll actually code up our own one. So this is a valid interface here, and typically you will put interfaces in their own file. So just like a class, it gets its own file. This is a public interface called drawable. The naming of interfaces, so in this case, drawable, there are some conventions depending on the language that you use, but oftentimes you will notice that an interface might end with something like able. So drawable or movable, or if you're making a game, killable, that sort of thing, because it's mostly meant to represent some sort of action. The only method in here, so notice we leave off the public, it's just void draw. This creates a contract. Any class that implements drawable must have a draw method. So that brings us down to our actual class here, our class rows. Rows implements drawable. So there's our keyword, implements. It implements drawable. Because of this, it must have this function draw. It has to. And you can do whatever you want in there. It's totally up to you as to how you write this function. In this case, it's doing a little sort of ASCII rows, but it could be whatever you wanted in here. If this was some sort of graphics thing as well, you could have JavaFX graphic stuff and sort of drawing a rows that way. So it can be whatever you want, but it must have this drawable. Now, if I come down to main, so class that contains main, this is more polymorphism. I can create a drawable object called D that is a rows, because rows implements drawable. So rows is drawable. And then I can do d.draw, because every single drawable must have the draw method, because that's the contract. If you are drawable, you have a method called draw. So interfaces get us polymorphism, just like inheritance. Inheritance gets us polymorphism, so do interfaces. They're another way for us to do this style of code. So you could create a whole bunch of classes that all implement drawable. We could have roses and faces and all sorts of other classes that implement drawable, and they could all be classified as a drawable. So you could make a drawable array, just like we had a pet array that contained dogs and cats. We could have a drawable array that contains any classes that implement drawable. And we're guaranteed that they will all be able to use the draw method, because that's the contract. So the interface contains a draw method. Rows implements drawable, so it must override draw, and new rows can be typed as a drawable. That's our polymorphism. That's a way to get polymorphism. And interfaces are super useful. They're probably more useful than abstract classes. Yes, abstract classes can help you sort of write less code and stuff, but these give you a lot of flexibility. Interfaces give you tons and tons of flexibility. In the game dev class that I teach, one of the games that we make, we use some design pattern stuff, and in there we've got interfaces that allow us to create any kind of it's a thing called a product, create any kind of product that we want, and store them into an array using polymorphism, because the interface gives us this sort of amazing power and flexibility. So when we look at UML diagrams, the inheritance one is extends. A class extends another class. A class implements an interface. And when you have that sort of relationship, you use the dashed line. So if it's a class implementing an interface, it's a dashed line instead of a solid line. Interfaces can actually also extend other interfaces. So that keyword extends is what you use in that situation, and it is a solid line for that. So an interface can extend another interface. So you can actually have interfaces connected together as well. But most of the time, these are the two that you're going to see. Now, if you look in the Blackjack game PDF, I don't use any interfaces there. I certainly could use interfaces there, but that's something that I sort of didn't want to throw in for that one. So you're not going to see that at the very least in the Blackjack game. So we'll look at sort of some other cases, other sort of larger cases in the future. All right, so let's think of a more complex example sort of related to this. So down here at sort of our lowest level here, we've got an apple and an orange. So apple and orange class, these are going to be concrete classes that you could create. You create a new apple, create a new orange, whatever you need to do. Those extend fruit. So fruit is the parent class of apple and orange, just like our sort of pet and dog cat. That fruit implements the edible interface. And you could probably put other methods in here, but we got one called like get calories. So that's the method that fruit must implement, which it probably doesn't. It probably just sort of passes it along to apple and orange. So we can get the calories in an apple, get the calories in an orange, because it's edible. Now, a chicken and a tiger are animals. They're not fruits. They're animals. So these would have this inheritance relationship up to animal. An animal, would probably be abstract, just like our pet class. And, might have something like make sound. So a similar sort of thing to pet. Now, typically, we don't think of a tiger as being edible. But a chicken, you could think of a chicken as being edible. So tiger would not implement edible, but chicken could. So this gives you sort of that power of interfaces, this sort of idea, where even though the chicken is an animal, it can also be edible. And think about the sort of terminology I just used there. I used is a and be. Chicken is a animal, just like apple is a fruit and orange is a fruit. But chicken is edible. Apple and oranges, and fruit, sort of by extension, is edible. So a chicken can be edible, a tiger might not be edible. An apple can be edible, an orange can be edible. So this gives you more flexibility in what a particular class is and is not. So by this diagram, a tiger is not edible. It is an animal and it is not edible. A chicken is an animal and is edible. So a lot of times when you see these sorts of diagrams or when you see interfaces, they are meant to represent things that, in this case, like a chicken, is and is not. And interfaces give you more flexibility in defining what that is, because we know a chicken is an animal. And if that was sort of where we left it, then we would have to do something special for the chicken to sort of say that it was edible. But by using the interface, we can just implement edible, and that's it. It is edible. It is an edible it isn't sort of an editable class. All right, so I think the next one here is an example that we're going to code up. So we're back to the sort of dumb example of the rectangle and the circle. But we're going to use an interface along with this. And then I'll show you what the usage would look like. So we're going to use a measurable interface, which has two methods, get perimeter and get area. And then we're going to create a rectangle and a circle class that implement measurable. So if we go over to Eclipse, I've got just a main at the moment. So I'm going to create, actually, make this a little bit bigger. Let's see. Go. Okay. So let's create this measurable interface. So I'm going to say new, and instead of class, right below class in Eclipse is interface. So I'm going to say interface, and I'm going to call this measurable. So be measurable. It's going to be public. There's not anything else that I'm going to add to this. And here's our measurable interface. Notice that the highlighting is also a little bit different, the color of the name here. Now I don't need public. That's automatically in there for us. So I'm just going to have just two methods. They both return doubles. One is called get area, and the other one will be called get perimeter. Just like that. And that's it. That's the whole interface. But again, it creates a contract. Anything that implements measurable must include these two methods. So in that same project, I'm going to create a new class, and we'll call this one circle. Say finish. And I want it to implement measurable. So I'm going to say implements measurable. Make sure I spell that right. There we go. So we implement measurable, and immediately we get an error for circle. That's because we have to add those unimplemented methods. So I'm going to do that. I'm actually just going to hover over circle and say add unimplemented methods. And it actually puts those in for me. The two methods that are in the measurable interface, it throws them in. It automatically gives like a return value and stuff that we're going to change. I should also put in a constructor and probably a variable for the radius. So let's do a private double radius. This, and we'll create the constructor as well. So public circle, and let's say it takes in a radius when we create it, and then we'll just say this dot radius equals radius. So just to get the sort of the circle ready to go, and then we'll just fill in this get area and get perimeter, and then we'll be done with the circle class. And we'll do the same thing for a rectangle as well. So I'm going to delete the return and the comment here. And the area of a circle is we're just going to return it. It's just going to be math.pi times radius times radius. Now, yeah, this is pi r squared. I didn't use math.pow because typically with sort of 2 or 3, so like a square or a cube, I typically just write the variable out multiple times, but you could use math.pow here if you wanted. So that's an easy one. Same thing for the perimeter. We're going to do return, and then we'll say 2 times math.pi, so 2 pi times the radius. And that's my perimeter. So a very easy circle class, sort of nothing crazy here. Let's write the rectangle class as well. That will also implement measurable. So we'll do that as well. We're going to do class, we'll say rectangle. And one of the things you'll note, and I've pointed this out before, all the stuff below where you put the name for this is things that we can do to it. And so one of them is interfaces. So I can actually add an interface. So we want measurable here. I can actually add the interface already. So notice it added it in there. Just say OK. And there we go. So this will actually put the interface in so I don't have to type it. I don't use this very often because I typically just sort of go through quickly and then just type it myself. But if you want it to do it for you, you can do that. So I say finish, and here we go. it automatically puts in implements measurable, and it automatically put in the methods as well. So I didn't have to go through sort of those extra steps. But typically, when you see me do this for class and in sort of examples we do, I will type it in sort of manually, so that you don't see me create a class and then you get all of this stuff that comes with it that doesn't sort of normally happen. So this is an option if you want to sort of quickly get everything. But again, for the examples and stuff, I will likely just type it in myself. So for our rectangle, we've got a couple of variables. So we'll create private. We'll make them doubles, and we got a height and another double for the width. I'm just going to call them H and W. And then, of course, our constructor, so public rectangle. And this one is going to take in a height and a width. So I'll say double height, double width. And here I don't have to use this. I can just say H equals height and H equals width. So that sets up our rectangle here, and then we'll just use get area and get perimeter. So for the area, we're just going to return H times W. Easy enough. And for the perimeter, we're just going to return 2 times the quantity, H plus W. And that's all we need to do. So very simple classes, sort of nothing crazy. You know, we messed around with circle and rectangle previously when we did our sort of overview of just general sort of OOP. So this should be sort of very familiar, very easy classes. The biggest thing to remember here is that because we implement measurable, we must have get area and get perimeter. So let's go back to main, and let's do some calculation stuff. Let's do some sort of printing things. I think we'll make a method that sort of goes along with this as well. So underneath main, I'm going to start with because this is in the same class as main. I want to call it from main, so I do need to make this public static, and we'll say void. And this is just be print, and I want to print a measurable. So this is where some of that polymorphism is coming in. I want to take in a measurable, any measurable. Anything that implements measurable can go in here. So my circles and my rectangles could go in here. Now that means I don't want to do anything specific to a circle or a rectangle. If I had extra methods like, get radius or something, that would be specific for a circle, not for a rectangle. So I wouldn't want to do some call like that. I couldn't say m dot get radius because a measurable may not have a get radius function. The only thing we know for sure is that a measurable must have get area and get perimeter. It must have that. So we can use that in here. So let's do a printf. And let's just do something like p equals, so like for the perimeter or something, we'll do like a %.3f. And then maybe a comma, and then maybe for the area, we'll do the same thing, %.3f. And I don't know, probably a new line after that. And then we'll say m, that's my measurable that comes in, dot get perimeter, and m dot get area. So measurables are guaranteed to have these, so I can use them on any measurable. So now, let's actually create a measurable. Now, measurable is any sort of interface we can't actually create, but I'm not going to create a measurable object. I'm going to create this as a new circle, but I'm going to type it as a measurable. Let's put in like 5 or something. So even though I'm creating a circle, I'm saying I'm typing it as a measurable. Same thing for another one. Let's create a rectangle. Measurable m2 equals new rectangle. And we'll send in like 2 and 3. Sure. So these are both measurables. So I can send them into my method print. So print, we can send in m1. And I can print, send in m2. And if we run it, we see there's our 2 prints. Looks like my area here is not what I want it to be. Let's check on that real quick. H times W. Oh, yep, right here I put my H as both of them. So you may have noticed that when I originally typed it, I did not. So this should give us hopefully something that we want here, or at least a fix for that. There we go. So there's our two values, hopefully corrected. So the idea here is that these are measurables. It's polymorphic. A circle is a circle and it's a measurable because of the interface. So there's no inheritance relationship happening here, but we can still achieve polymorphism. Now, you may wonder, okay, what's going to happen if I put a circle in here? Because a circle is a measurable. So if I create a circle C1 and have this be a new circle, and maybe a different radius or something, what if I try to print C1? It still works, or at least it still looks like it works. Let's try it. There we go. So it still functions correctly. I send a circle in, Java automatically knows, hey, a circle is a measurable, so we can just use it. So again, that's where the polymorphism comes in again. Not only can we type the circle, our circle object, as a measurable, we can just directly use a circle in something where it has that property, that measurable property, that measurable interface. So that's the power of these interfaces here. And that's something that is not going to become probably as apparent unless you sort of start working with these a bit more. But this is one of the ways that we're going to get to actually doing our sort of interaction with our JavaFX stuff, because interfaces do more for us than what I've shown you here. So back to the slides. So and I have all the code here. I think in the main I didn't show that you could just create a circle and then send that circle in, but that is what this is actually doing here for the rectangle. So I created a couple measurables, sent them in. This one here is creating a rectangle and sending it into the method, and it still works. So it sort of does show both those things, just not exactly the way that I coded it up. So interfaces, the sort of second lecture for week 6 here, interfaces give us the capability to use what's known as a lambda function, and that's going to be some of what we talk about in the next lecture. So interfaces to next time. All right, so the second part of what I wanted to do in this lecture is just talk a little bit about the starter code for PA3. I don't specifically, let's see, let me go back to here. So I don't specifically want to talk about sort of all three of them, but I'll talk about A and B. C is going to be very similar to B. So let me increase the size here. So just like in all of our other assignments so far, you're going to get some strings. In this case, you also get some chars. I sort of say, don't change these, but you can take a look at the errors, and you can take a look at sort of what these sort of quote chars stuff is here. This one, remember, A was the one where you type in a phrase and you give a bunch of information, like how many characters is it? What's the shortest word? What's the longest word? That sort of thing. So definitely take a look at the PDF for that description and the output that you're supposed to see. So I do recommend starting from the top and working your way down. The first method here is find shortest, and it takes in an array. This array is the input sort of phrase or sentence or whatever it is the user typed in, and a Boolean. What this method does is it looks in that array, so those array of words, and it's going to return the word that has the minimal length from the beginning or from the end. So if you start in the beginning, Boolean will be true. If you start from the end of the array, the Boolean will be false. So that's what you have to think about here. And that's what it says. So first, if true, return first minimal length element, otherwise last. So there's sort of two ways to think about that, the sort of starting from the beginning of the array and starting from the end of the array, or you could start from the beginning of the array in both situations, find the first one, the first sort of minimal length element. So in other words, if you had like a one letter word like I or A or something, then you would find the first one that you come across starting from the beginning. If the Boolean is false, you're either going to start from the beginning and find the last one, or you could start from the end and find the first one. So there's a couple of ways to think about this. Essentially, you're just looking through the string for the shortest element. That's really all you're doing, and you're going to return whatever that string is. So take a look at the examples in the PDF. The next two methods, they are not what you're going to change, but they are what you're going to use. In main, you're going to use these methods. Notice what this says. First shortest element. And it calls the method you wrote with true. Just like here, last shortest element calls the method you wrote with false. So you don't need to change these, but these are what you're going to use in main. You'd never have to call this method yourself. You're just filling it in so that you can call these two methods. The next two are exactly the same. Or the next one here is exactly the same. But instead of the shortest, it's the longest. So once you have the shortest working, so you start up here at the beginning, you get this one working, you can just copy and paste this code into this one and make sure that instead of finding the shortest word, you're finding the longest word. So this one will be hopefully relatively easy once you finish the shortest one. And then it has two methods as well, that first longest element, where it calls the method you wrote with true, and then one where it calls the method you wrote with false. So you don't have to change these, but these are what you're going to be calling from main. All right, the next method you write is find of length. It's the same thing again. It's literally the same thing, except you specify a length. So we had shortest, longest, and then one where you tell it what length to send or what length to look for. So you can copy and paste what you did before and make sure that instead of the shortest or the longest, you're finding the appropriate length. So this one's not too much different either. And again, first of length and last of length. One sends with true, one sends with false. So you will be calling these methods from main, not the method that you wrote here. So those first three methods that you have to write, shortest, longest, and of length, they're almost identical. There'll just be some small sort of subtle changes. All right, the rest of them are sort of not exactly the same as those first three. So this is going to be sum of element lengths. What are the lengths of all the words that are in the array of all the words that the user typed? So how many characters did the user type? It's going to exclude spaces. So that's something to consider, but that's essentially what it is. Just what are all the lengths? So this is a sum. So it's going to be similar to those sum arrays that you've written before. You start with sum equals 0, do a loop over the entire array, and in this case, get the length of each element and continue adding that to the sum. So this is a very short method. Average as int. So you're going to get a sum and a count, and you're going to round the average of sum and count. So sum divided by count gives you the average. You're going to round that in the sort of natural way. So if it's, if you get like 10.5, you're going to round that to 11. If you have 10.4, you're going to round that down to 10. So it's your sort of natural rounding way. Has duplicates is going to look through the array and check if the contents is the same. Not the same identity, but the contents. So you're going to use a dot equals, and you're going to check if there's any duplicates in the array. Flexible quote is one of these where you can sort of choose the sort of opening and closing quote around something. So you have a string, and we have a couple of chars that they get taken in. What's going to happen here is that the string that comes out of this, so let's say the open quote or the open char is this and the closed char is this. So let's say this is what comes in. And let's say the string is hello. The output string of this needs to look like hello. That's what the output string needs to look like. So this just you take the open char and you put it on the left, take the closed char, put it on the right, and make sure the string is in between. And that's what comes out of this. So I think it's better to sort of show what this actually does rather than just in words explain it. So hopefully that makes sense. This is not going to be a long method. All right, one, none, or both. This returns a string. And make sure that you read the rules up here, because it depends on what comes in. So we have a first string and a last string. If both of these are null, so if this one is null and this one is null, then the string you send back is none, just like that. If either one is null, so as an example, let's say the first string is hello and the second string is null, then you send back the one that's not null with the open and close char. And we already wrote a method that takes a string and puts it in the open and close char. That was the method right above. So this would return hello, like this. If the same string is provided twice, now that's a tricky one. Identity, not content. So if S first equals S last, in other words, they're the same in memory, then you return either one with your two quotes. You just pick one and you use it if you have that equals situation. Otherwise, so the last case, maybe we have hello and world. Then you're going to sort of print the most complicated thing. You're going to put first, so the string that comes back from this will be first equals hello, comma, last equals world, with those sort of angle quotes if these were the angle quotes. So follow these rules. It's just going to be if statements. If S first and S last equals null, then you're going to return none. If either one is null, so one or the other is null, then just return the other one with the quoted stuff. If the same string is provided twice, so if S first equals S last, then return either one, doesn't matter. Otherwise, do it like this. So hopefully that makes sense with that example. Again, just follow the rules that are up here. Print with separator is, this one can be a little bit finicky in that you have to think about a lot of things. So this is a utility method that it just helps you print stuff with various separators before and separating values and after the values. Notice how it takes in the whole string. So it takes in all the words the user typed in. So let's say this string here was an underscore, and let's say this string here was a dash, and let's say this string here was, I don't know, it doesn't really matter, an at. Let's say our two elements here in A, let's say it's hello and world. So let's say it's like that. So our print that we actually do with this, so this is print with separator, so you will be printing here. Our print that we actually do will be, before we print anything, we're going to put the underscore. Then we're going to put the first word, hello. And then we'll have a separator between our first and second word, which is the dash. And then we'll put world. And then after we print everything out, we'll put the after one. So we'll do this. Now, of course, those strings could be anything. They could all be spaces. Maybe before is just an empty string and after is an empty string, and the separator, the center one there, maybe that's just a space. So it could be whatever you want it to be, or whatever it needs to be for the particular problem. But that's the idea. The first thing that you put in the string that you print is the before. You put each of your words from the array, and between each of those words from the array, you put the separator. And then after you print everything else out, you put the after. So that's the idea of this one. So yes, you will need a loop because you'll be going over the array, and you'll need to make sure that you print these in the appropriate spots. And of course, the unit tests have a whole bunch of tests for a bunch of different cases for this. All right, valid args. This is something where you want to make sure that there's at least one string in here. So that's a relatively easy one. True if the input is non-zero length. So as long as there's at least one string in there, then this will work fine. And then main. It says don't change this method. So I've already done all this stuff for you. Notice how there's print with separator. There's calls to sum of element lengths. There's find of shortest, or first of shortest, last of shortest. Notice how those are the ones that are called, not the ones that you specifically wrote that take in a particular Boolean. So that's the idea here. You don't have to write main. Main will just work for you, but you do, of course, have to write all the methods so that this does work for you. All right, let's take a look at B real quick. So this is the one where you have to supply 6 numbers. And I give a couple of strings here for you, of course. Please supply six numbers. An error for the equation has no solution, and the number of parameters here, you can use this when you check. It should be 6. There's only 2 methods in this main class. Validate args, so make sure that 6 args come in. And then main. Main itself is where you're going to make sure that you read in those args. And I'm going to talk about the command line arguments here in just a second. That'll be the very last thing that we do, because you're not going to be reading in using a scanner. That's something I want to make very clear. In any of these A, B, or C, you are not using a scanner to read in the values. You are using the command line arguments. So I'll show you that in just a moment. So then we have main. So in main, you're going to be creating a linear equation class. So you will be instantiating some classes in here. The linear equation class is here for you. And you will need to put the data in. So there's no data set up for this right now. You will need to put this in. So you have to put in the data. So make sure that you create A, B, C, D, E, F. Probably going to need X and Y as well, as those are the solution. And it has 2 constructors. One that takes in 6 elements, and one that takes in an array. And that array is assumed to be those 6 elements in order. So the first element's A, second element's B, and so on. This must be one line. So I say must call the above constructor. This is one line. You don't put anything else in here other than one line. I'm going to let you figure out what that one line is. But that must be one line. And in fact, it's going to be one method call. So do not do anything else other than the one line for that. In here, in this top constructor, you're going to do the normal stuff you've seen me do for a bunch of constructors that we've written. You're going to say this dot A equals A. This dot B equals B, and so on. Then we have a bunch of getters. These are very short. Get A, get B, get C, get D, get E, get F. This should make sense. Is solvable. You need to return a true or a false for that. Returns true if the equation is solvable. In other words, the denominator can't be 0. The denominator on both x and y for the solution is AD minus BC. If that is 0, the equation is not solvable, and you must return false. Otherwise, you can return true. Then we have get X, and get Y. You're going to check in these methods. The first thing you're going to check is solvable. So I'll be solvable. Let me retry that. You're going to check is solvable first. You're going to call this method first. If it's not solvable, you're going to return null. If it is solvable, so if is solvable comes back as true, then you're going to use the equation from the PDF to get the number, and that's the number you're going to return. Same thing for get Y. So both of these are almost the same, except the equation is slightly different. Now, the key here is that if it's not solvable, you're going to return null. So you have to deal with this in main. You have to deal with this in some way in main. So if you try to get X in main and it comes back as null, then you know that there is no solution, and you can print out that error message, there is no solution. So this one is relatively easy. Most of the methods here are just your standard getters, a couple constructors that you have to mess with, and then something where you're calling is solvable to return the appropriate number. So this one's not too bad. In fact, the other one, C, is not too bad either. C, I actually even do some of main for you as well, so you can take a closer look at that. And I'll probably talk about that at some point in the near future as well. Now, one last thing. Go back to Eclipse, and I have a quick, just a quick method here. Just a quick main, and I'm going to use this string array. So I'm just going to do a quick for loop. I equals 0, I less than args dot length, I plus plus, and I'm going to print out as a string, and then a new line. I'm going to print out args I. So I'm going to print out all of the elements of this array. And if I do that right now, it's empty. There's nothing in it. But these are the command line arguments. So in your homework, this will be where the values come from. This will be where you have your A through F, for example. You're going to have a bunch of values. They're all going to be strings, so you will need to, in some way, convert those to numbers. For part A, so for PA3A, you're going to have all the strings of all the words that somebody entered, for example. If you want to manually test, you need to at least run the program once, and then you'll right-click on the project. You'll go down to Run As, Run Configurations. Make sure that it's the correct project and the correct class. So this is my CLI for command line interface, and this is the main class. So this is the correct one. I go over here to Arguments tab, and I can put in numbers. For example, here I can say 1, 2, 3, C, 1, 2, 3, A, B, C, just like that. I say Apply, and I run. And there's my 1, 2, 3, ABC. So if you want to manually do it, you put the arguments into the run configuration, and they will come in from here. The unit test will sort of do all of this automatically for you. But if you want to manually test, this is how you do it, and this is where your values are coming from. So don't use a scanner. There's nothing that's going to be typed in from the user. All of it comes in from the command line. All right, so that is it. That's what I wanted to talk about for today. So the next lecture will be more on interface stuff.